The insulation level of an electrical panel signifies its capacity to resist voltage without permitting the flow of electrical current. When an electrical panel is rated at an insulation level of 660 volts, it implies that the panel is designed and manufactured to safely manage electrical potentials up to 660 volts without experiencing electrical breakdown or short-circuiting events. This specification is paramount for ensuring the safe and reliable operation of electrical systems, particularly in settings where higher voltages are prevalent. In essence, the insulation acts as a barrier, preventing unintended current paths and safeguarding against potential hazards. The selection of an appropriate insulation level is a critical aspect of electrical design and must align with the operational voltages within the system. In scenarios where the voltage exceeds the insulation rating, the risk of insulation failure escalates considerably. Insulation failure can manifest in various forms, including arcing, trekking, and complete dielectric breakdown, each posing a significant threat to equipment and personnel safety. Arcing involves the formation of a conductive plasma channel through the air or along an insulating surface, capable of generating intense heat and causing ignition of nearby materials. Trekking, on the other hand, refers to the gradual formation of conductive pathways on the surface of the insulation due to the accumulation of contaminants and moisture. Dielectric breakdown represents the catastrophic failure of the insulation material, resulting in a direct short circuit and potentially explosive consequences. The 660-volt insulation level is commonly encountered in industrial and commercial environments due to the presence of high-voltage equipment. Industrial facilities often employ machinery and processes that necessitate voltages exceeding the standard residential levels of 120 volts or 240 volts. Similarly, commercial buildings may utilize higher voltages for lighting, heating, ventilation, and air conditioning systems, particularly in larger structures with substantial power demands. The utilization of 660-volt insulation levels in these applications is a direct response to the increased electrical stress imposed by the higher operating voltages. It ensures that the electrical panels and associated components can reliably withstand the voltage without compromising safety or performance. The insulation material used in electrical panels plays a pivotal role in determining the overall insulation level. Common insulating materials include polymers, ceramics, and composite materials, each possessing unique electrical and thermal properties. Polymers, such as polyethylene, polyvinyl chloride, and epoxy resins, are widely employed due to their flexibility, ease of processing, and good dielectric strength. Ceramics, including porcelain and steatite, offer exceptional high-temperature performance and resistance to chemical degradation, making them suitable for demanding applications. Composite materials, such as fiberglass-reinforced polymers, combine the advantages of multiple materials to achieve specific performance characteristics. The thickness of the insulation layer is another critical factor influencing the insulation level. A thicker insulation layer generally provides greater resistance to voltage breakdown. However, increasing the thickness may also impact the size, weight, and cost of the electrical panel. Therefore, selecting the appropriate insulation thickness involves a careful trade-off between performance, size, and economic considerations. Furthermore, the design and construction of the electrical panel significantly contribute to its overall insulation level. Sharp edges, corners, and burrs can create localized electric field concentrations, increasing the risk of voltage breakdown. Therefore, electrical panels are typically designed with smooth, rounded surfaces to minimize electric field stress. Proper grounding and bonding techniques are also essential for maintaining a safe and reliable electrical system. Grounding provides a low impedance path for fault currents to flow back to the source, facilitating the operation of overcurrent protection devices such as circuit breakers and fuses. Bonding ensures that all metallic components within the electrical system are electrically connected, minimizing the potential for voltage differences and preventing shock hazards. It is important to note that the 660-volt insulation level represents a maximum voltage rating. The actual operating voltage within the electrical panel should always be maintained below this level to provide a safety margin and prevent premature degradation of the insulation. Regular inspection and maintenance of electrical panels are crucial for ensuring that the insulation remains in good condition. Visual inspections can identify signs of damage such as cracks, discoloration, or contamination. Insulation resistance testing using a megameter can assess the integrity of the insulation by measuring its resistance to current flow. Low insulation resistance readings indicate potential insulation problems that require further investigation and repair. In summary, a 660-volt insulation level in an electrical panel signifies its ability to safely withstand voltages up to 660 volts without the risk of electrical breakdown or short-circuiting. This level of insulation is commonly used in industrial and commercial applications where high-voltage equipment is used. Proper selection, installation, and maintenance of electrical panels with appropriate insulation levels are essential for ensuring the safety and reliability of electrical systems. When dealing with electrical systems, it is crucial to adhere to relevant safety standards and regulations, such as those outlined by the National Electrical Code or NEC. These standards provide detailed guidance on the proper selection, installation, and maintenance of electrical equipment, including electrical panels, to minimize the risk of electrical hazards. For example, NEC Section 110.3 provides general requirements for examination, installation, and use of equipment. This section emphasizes the importance of using equipment that is listed or labeled for its intended purpose and installed in accordance with the manufacturer's instructions. NEC Section 230 covers service entrances, which are the point where electrical power enters a building. This section specifies requirements for service conductors, overcurrent protection, and grounding. NEC Section 408 addresses switchboards and panel boards, which are the main distribution points for electrical power within a building. This section outlines requirements for panel board construction, overcurrent protection, and grounding. NEC Article 310 provides tables for determining the allowable ampacity of conductors. These tables take into account factors such as conductor size, insulation type, and ambient temperature. It is essential to select conductors with sufficient ampacity to carry the intended load without overheating. Moreover, understanding the difference between insulation voltage ratings and working voltage is crucial. The insulation voltage rating refers to the maximum voltage that the insulation can withstand without failing. The working voltage, on the other hand, is the voltage at which the electrical equipment is designed to operate under normal conditions. The working voltage should always be lower than the insulation voltage rating to provide a safety margin. The selection of an electrical panel with an appropriate insulation level depends on several factors, including the operating voltage of the electrical system, the environmental conditions, and the type of load being served. In general, it is advisable to select an electrical panel with an insulation level that is at least 20% higher than the maximum operating voltage. This provides a safety margin to account for voltage fluctuations and transient overvoltages. Furthermore, it is essential to consider the environmental conditions in which the electrical panel will be installed. Electrical panels installed in damp or corrosive environments may require special insulation materials or enclosures to protect against moisture and chemical damage. The type of load being served by the electrical panel can also influence the selection of the insulation level. Electrical panels serving inductive loads such as motors and transformers may experience voltage transients due to switching operations. In these cases, it is advisable to select an electrical panel with a higher insulation level to withstand these transients. In addition to the insulation level, other important considerations when selecting an electrical panel include the short-circuit current rating, the busbar ampacity, and the enclosure type. The short-circuit current rating refers to the maximum amount of current that the electrical panel can safely withstand during a short-circuit event. The busbar ampacity indicates the amount of current that the busbars within the electrical panel can continuously carry without overheating. The enclosure type provides protection against environmental factors such as dust, moisture, and corrosion. Regular inspection and maintenance of electrical panels are essential for ensuring their continued safe and reliable operation. Visual inspection should be performed regularly to identify any signs of damage, such as cracks, discoloration, or corrosion. Electrical connections should be checked for tightness to prevent overheating. Insulation resistance testing should be performed periodically to assess the integrity of the insulation. Any damaged or deteriorated component should be replaced promptly. The electrical panel should be kept clean and free from dust and debris. Dust and debris can accumulate on the insulation and reduce its effectiveness. It is also important to ensure that the electrical panel is properly grounded and bonded. Grounding and bonding provide a low impedance path for fault currents to flow back to the source, facilitating the operation of overcurrent protection devices. Finally, electrical work should only be performed by qualified and licensed electricians. Electrical work can be dangerous and should only be performed by individuals who have the necessary training and experience. Adhering to these guidelines will help ensure the safety and reliability of electrical systems and prevent electrical hazards. It is also worth noting that advancements in insulation technology have led to the development of newer and improved insulation materials with enhanced performance characteristics. These materials offer high dielectric strength, better thermal stability, and improved resistance to environmental degradation. The use of these advanced insulation materials can contribute to the overall safety and reliability of electrical panels. In addition to the materials used for insulation, the design and construction of the electrical panel play a crucial role in ensuring its ability to withstand voltage stress. Factors such as the spacing between conductors, the shape and smoothness of conductors, and the presence of sharp edges or points can all affect the electric field distribution within the panel. Sharp edges and points can create localized concentrations of electric fields, which can increase the risk of voltage breakdown. Therefore, electrical panels are typically designed with smooth, rounded surfaces to minimize electric field stress. The spacing between conductors is also an important consideration. Insufficient spacing can lead to arcing between conductors, especially at higher voltages. The NEC specifies minimum spacing requirements for conductors based on voltage levels. Furthermore, the manufacturing process of electrical panels can impact their insulation performance. Quality control measures are essential to ensure that the insulation is properly applied and that there are no defects or imperfections. Testing and inspection procedures should be implemented to verify that the electrical panels meet the required insulation standards. In conclusion, the 660-volt insulation level of an electrical panel is a critical parameter that determines its ability to safely withstand voltage stress. Understanding the factors that influence insulation performance, such as insulation materials, design considerations, and manufacturing processes, is essential for ensuring the safety and reliability of electrical systems. Regular inspection, maintenance, and testing of electrical panels are also crucial for maintaining their insulation integrity and preventing electrical hazards.